All right, so we've done two things already, the circumcenter and the orthocenter. Take a wild guess what the third one's going to be.
Intercenter.
It's not an inner. It's just what? Just in center. It's right there. There's no circle. It's in center. In center. It's actually, this lesson's actually two of them. Shh. We're not doing this anymore. You guys have miraculously turned into like a real class, a real academic class in the last few days. All right. Let's not break the streak. All right. You're 2 for 2, a good 2 for 2. Let's make it 3 for 3. Okay. So watch. We're doing in center. Now there's another one in this section, but the reason I called it part A is because we're not going to do the second one today. We'll do the second one tomorrow. That changes our lesson plans just a little bit, but I just don't think we're going to have enough time to fit them both in and give them both justice. All right. So anyway, today we're just doing the in-center. The other one that we're going to do, if you have your book in front of you, is called the centroid, but today we're going to do the in-center. All right. And yeah. And we're actually, if we have time at the end, I actually have a visual aid that I made that I'm going to show you that has to do with the in-center. All right. If we have time. Oh, I'm handy, man. That's right. All right. So let's talk about this first of all. Let's talk about this word. I'm just going to write it down here, and then we're going to go to the GeoGebra program and use that the rest of the time, okay? So I want to talk about a thing. Oops, I got to change my pen settings up here. Always forget to do that. All right. So I'm going to talk about a thing called an angle bisector. An angle bisector. Yes. No, they didn't. All right, so what do you think an angle bisector is?
It's
So-
like a perpendicular bisector, except it's on the vertex, I'm guessing. Like, instead of being...
Well, it's angle, right? It's angle, so there's an angle right there. Should put that right up against there. There we go. Okay. But it's a bisector. What does it mean to bisect something? What does the prefix bi mean? It means two. Okay, and we're going to bisect it, like intersect it. We're going to cut it, divide it, right? We're going to cut it or divide it into two. Not just any two, but what's going to have to be, let's use yellow.
Right down the middle of the...
Is it going to go here? Is that bisected?
No.
Is it bisected here?
No.
Okay, it splits it into two. Isn't that what you said it does? Cuts it into two? But it cuts it into two what? Equal angles. So I'm just eyeballing it. Does that look about equal? That's close enough. All right. So if, and these are all raised. I'm not really that concerned about putting the arrows on there, but we'll do it anyway. All right, so that means that if this angle and this angle are equal to each other, what do we call this ray right here? We call it the angle bisector. It's right in front of you, okay? I'm trying to make it easy for you. All right, so it's called the angle bisector. So the angle bisector is a what? Is it a line segment? Is it a line? Is it a ray? Is it an angle? Is it a quadrilateral? What is it? What bisects that angle? A ray. That's right. A ray is an angle bisector. Everybody got it? Okay. So now what we're going to switch over, hopefully, to GeoGebra. Let's click out of that. There's GeoGebra. And we're going to do an angle bisector. And the angle bisector has something to do with the triangle, okay? Remember the first time we did circumcenter, we talked about what a perpendicular bisector was. And then we applied it to that triangle. Then when we did orthocenter, we talked about what an altitude was, and we applied it to the triangle. So now I'm going to show you what angle bisector is, and guess what we're going to do with that? We're going to do what? Apply it to, it's the third time, come on, get the pattern, to the triangle. We're going to apply it to the triangle. Thanks for playing along. All right, so let's do this. Does this just make a regular angle? I don't think so. I think. Do we have a thing that just makes an angle? I don't see anything. No, that tells you the measure of the angle. So let's just I'll just use a segment and just go from here to here. Okay, and then I'm going to go from here to here. All right, so there's an angle, kind of looks like what we did before. And I can actually figure out what the measure of that angle is. So if I click that angle word right there and click on this and click on this, it actually tells me what the measure of that angle is. Okay, now what I'm going to do, I think I should have practiced this. There we go, angle bisector. I knew it had one. What I'm going to do is click on angle bisector, and I believe, let's see, I think I click on this, and I click on this. Boom, there it goes. Now, for some reason, it makes this line right here, which is weird. I can get rid of that, and if I click on that and click on that, there, we got rid of it. Now, we said the angle bisector was a ray, but this keeps on going. So this basically is a what? It's a line, keeps on going. Okay. So what I'm going to do, just to make it look like a ray, I'm going to make segment, and I'm going to start here. I'll tell you what, I think I have to put a point. Let's try this. I'm going to put a point right there like this, and then make a segment. We're almost there. Don't lose me yet. We're going to go from here to D. All right. And so now I got a segment. So now what I want to do is I want to get rid of this thing. I wonder if I can just hit delete. Oh, no, that's not what I want. It's not what I want. Click on that. Shh, guys, settle down. Let's get rid of that. There we go. And that's what I want. Okay, so check this out. I can actually, the cool thing about GeoGebra is I can move this around. I can change the angle, right? You see the angle number changing, all right? But that angle bisector, it still stays in the middle of whatever angle that I make. Do you see it? So that means that this angle right here should be the same as this angle right here. Agreed? Let me get rid of that angle. And so now let's go back to this and just show you on here that this angle, I think, there we go. Let's move it out a little bit so we can see it. That's 24.7. And let's do the same thing with the other one. What should the other angle down there be? It should be 24.7. Let's hope it is. It is. And there we go. So again, if we do this, if I take this and move it around, right, it still is exactly the same. Notice, it's exactly the same every time because we bisected the angle. All right? So we understand what an angle bisector is now, right? Okay. And I just kind of showed you with this program that these angles are exactly the same. Oops, I didn't want to do that. I want to do this. Let's get rid of that. Now what we're going to do is we're going to apply that to a triangle. So let's make a triangle. So I come over here at polygon, boom, boom, boom. Oops, what happened there? There we go. I don't know what happened. All right, so there's a triangle. Right? I can move it around. I can change that. I can do whatever I want to it, basically. Okay? So what do you think I'm going to do to this triangle? What did we just talk about? Think of what we just talked about. So what do you think I'm going to do? I got heads down. I need heads up. Okay? Logan, eyes open. So what do we think we're going to do to each of these angles? We just talked about doing something to an angle. What do you think we're going to do to the angles of the triangle? Trevor, tell me. We're going to bisect all the angles. Exactly right. So here we go. You ready? We're going to bisect all these angles. So I've got a thing right here. It says angle bisector, just like I did. So bear with me. So let's take point E. Let's take point E. I'm going to hit that side. I'm going to hit this side, and it's going to bisect it. I'm going to do the same thing with this side, and it just bisected it. Now, what do you think is going to happen when I bisect the other one? What do you think is going to happen about that, the line? They're going to meet right there at that point. What do you think that point is called? It's called the incenter, because that's the name of this lesson. All right? That's right. So let's do this. Click on this one, and there you go. So that point right there is our what? Is our incenter. Okay? Incenter. It's not that hard. It's two little words. It's in, and it's center. Okay? It's incenter. It's one word. So I'm going to get rid of a lot of this stuff because it's all in the way. All right? So
Is it important later on?
it's not. those particular ones I'm getting rid of are not. Let's see, did I click on this? There we go. So get rid of that one. This one right here, I'm going to get rid of that one.
Why does the program put that?
I'm not really sure why it does. It makes it perpendicular. It's what it's doing. It's making it perpendicular, but I'm not sure why it's doing that. But we can get rid of them. It's good enough. All right. So now what I want to do is this. I'll keep those going all the way through. It's no big deal. What I want to do is put a point right here, right where they intersect, and let's call it, do this. I can name this, instead of calling it H, what do you think we're going to call it? How about Incenter? All right, so that's our Incenter right there. Oops, I keep hitting that button. Don't want that. Okay, now watch. Watch very carefully. Do I want to hear that? Do I really want to hear that? I know it's not affecting you. For goodness sakes, you're a wrestler. You should be able to take it, all right? So just take it. Oh, you're a basketball player.
That explains it.
Oh, that's right. That's actually a good one. I like that. Sorry. I was a basketball player. I played basketball. I used to play basketball. All right. I was a basketball player. All right. So here we go. What we're going to do is we're going to find out what is special about the Incenter. We reviewed this earlier. We said the circumcenter, it was special because it was equidistant from the three vertices. There was nothing special about the orthocenter, but the Incenter, there is something special about it. Okay? I should have talked about this earlier. I tell you what, I will. Let's go back to the other program, and I want to show you something. We'll come back to this, okay? So we will come back to that in just a minute, but let me do this. Oh, yeah, we kind of talked about this when we talked about altitude. So watch. If I draw a line, that's okay. It doesn't matter if it's perfectly flat or not. Okay, watch. If we have a line right here, and I wanted to find, and let's see, let's use my pen on this. If I had a point out here, again, we've talked about this. We talked about altitude the other day, right? Yes, was it yesterday? Talked about altitude. And I said, what is the altitude from a point to a line right here? Is it from here to here? No. Is it from there to there? No. It's from here where? Give me a better word than straight.
Vertical,
Perpendicular. It's perpendicular. Oh, goodness. All right. It's perpendicular. So here's another thing. If I asked you the distance, to find the distance from the point, we'll call it point A, we'll call this point B, okay? Right here. I'm sorry, not to the point. I shouldn't have said that. I shouldn't have said point B. Let's say the line, or the line segment, doesn't make any difference. I don't want an A because I've already used A. Let's go BC. I'm messing this all up. Okay. What if I ask you what the distance was from point A to line segment BC?
I could tell. Because there's no grid, right?
You done? If I asked you what the distance from point A to point BC was, okay, would it be from here to here? No, because you got to have some kind of consistency, right? If I asked you, if I had a point and I had a line, I'd say, what's the distance? I don't understand what's going on today. Why is today different? Shh, stop.
Something just happened. Like it left the whole.
Shh, stop. I'm sitting here. Just listen to me. It's all I want you to do. So if I asked you, if I gave you a random point anywhere on here, and I said, what is the distance from that point to this line? It would be the perpendicular distance. If I had a point right here, what is the distance from this point? We'll call it D. Whoops. Stop that. Okay. If I call it D, What is the distance from this point to this line? What would it be? It would be the what? Perpendicular distance. I could do this all day long. What if I had a point down here? Call it E. What is the distance from this point E to this line right here? It's the perpendicular distance, okay? So I'm doing this for a reason, okay? Because what we're going to see in a second, that special thing about the incenter, it's going to be the distance from a point to a line or line segment, okay? And you need to know that what is that distance? It's the perpendicular distance. Let's go back. Oops. Oh, man, I clicked on that. It's going to open up GeoGebra twice. Dumb me. And let's get rid of that. There we go. Okay, I think we're good. Yeah, let's get rid of that one. You kidding me? I have so many things I want to say to you. I'm not going to because you're lucky I'm being recorded. It's kind of calming me down a little bit. So let's take a look. The thing that's special about this incenter in this triangle is that it's equidistant, not from the vertices. That was the circumcenter. It's equidistant from the three sides of the triangle. Did you hear what I said? The incenter is equidistant from the three sides of the triangle. Guys, you're looking around. I can tell what you're doing. You're looking around like, what am I going to do to get on his nerves? What am I going to do to... I can see it. I can see it in your body language. I can see it in your eyes. You're not looking up here. You're looking around. I'm talking to you, Wayne, specifically. And you're looking around like, what can I do? I can see it. I can see it. So if you want to stand out in the hallway, I would prefer that, to tell you the truth. No, listen, I can tell. You can say all you want. I can tell. So let's stop. Let's stop. Let's end it. Let's stop it. So we're 2 for 3 now, by the way. So the thing that's special about this is that, I'll tell you what, I got to do perpendicular line. So if I hit perpendicular line, I go from this point to this line. It's going to make a perpendicular line, okay? Now, it's really long and all that kind of stuff, so what I'm going to do is just make a segment out of it. So I'm going to put a point right here, and I'm going to put a point right there, and then I've got my segment. So now what I'm going to do is get rid of that big long line because that just is ugly and it gets in the way. And, oops. And let's find that, get rid of it. There we go. Do you see that little line right there from the incenter to point H? That right there, and let's change colors so I can see it. Let's make it red, all right? You can see that red on that one, all right? So that right there is the distance from the incenter to the side of the triangle. So we're going to do that 3 times. And what do you think might be true about all 3 of those distances? From the incenter to this triangle, or to this side, I'm sorry, from this incenter to this side, from this incenter to this side. What do you think is going to be true about all 3 of those red lines? I'll make them red here in a second. Okay, they're going to be equal to each other, okay? So let's just give me a second, all right? Let me do this, and I'll show you that it's true. So again, I go to perpendicular line, I go from the incenter, and I go to this line, and there it is right there. Let's do it one more time. Incenter to this line segment right there. I missed it. Incenter to this one right there. There we go. Whoops, that's not it. What am I doing? Incenter to that. Oh, it's probably already there. Because that one's probably looks like it's already perpendicular. So what we'll do is this. Let's put a point. I think that's where it's supposed to be. Oh, come on. So I go from here to here. It's not showing me the point. That's dumb, but there we go. We got a point right there. I'm not sure what's happening to that point there. But what I'm going to do is this. Let's get rid of this line. And let's connect this one and this one. So I'm going to connect that segment to this segment right there. All right, so you see that one? And let's change it, make it red. Right there. There we go, finally. All right, and for some reason, this one is acting strange. Maybe you know what I should do? Is just change the shape of the triangle. There we go. See, I knew I had another line on there. So let's get rid of this right there. So this one now should work. Well, I thought it was. There's too many of them. I got a bunch of them. Yeah, because I was trying it like 3 or 4 times, and so it just put it over top of each other. There we go. So now, this one, now what I can do, still got 2 minutes. Don't pack up. Do not pack up. So if I go from the Incenter to that point right there, make a segment now from here to here. There we go. And let's get rid of this. This might be more trouble than it's worth. There we go. Let's get rid of that. There we go. That's better. And we're almost done. Let's make this red. Okay. So now, look at all 3 of those red lines right there. No matter where the Incenter is, and if you look at this, look where the Incenter. If I make this obtuse, the Incenter is inside the triangle. If I make it acute, the Incenter is what? Inside the triangle. If I make it right, the Incenter is what? It's inside the triangle. So the Incenter never goes outside. That's why it's called the what? The Incenter. Okay, so it's always inside it. So what's interesting about this, last thing before we go, what's interesting about this, I'll hit distance or length, is if I click on this, hopefully this works, that's 2.9, that's 2.9, and that is 2.9. All right, so all 3 of those distances are exactly the same. Tomorrow, I'll use this little triangle thing. I'll show you something kind of cool about finding the Incenter of something. Okay, there they are. There's all my lines. That's the Incenter lines right there.